Well, today I'm going to talk about using Postgres, not Rails, to make Rails faster. And actually, all the examples in here are going to be Rails specific, but this could be for any other system, whether you use .NET, PHP, if you're a masochist, Java. But yeah, a lot of this is potentially abusing Postgres. So I'm Dan McClain. I'm a partner at Dockyard. I maintain a few Ruby gems related to Postgres. I'll go through some of them as we go through this talk. I also was unfortunate enough to get an underscore in my Twitter handle. So we started out as a Rails consultancy. So we do a lot of work with Rails still. We do Ember JS as our main offering now. Rails has been getting really awesome Postgres support, especially with 4 and 4.1 and 4.2. Aaron Patterson, or Tenderlove, which has the most awkward domain, tenderloving.com. Thank you, tenderlovemaking.com, which is the most awkwardly but work-appropriate website you can find. He's been doing a lot of work, especially, like I said, with Rails 4. He rewrote the Postgres adapter, which makes it really easy to extend now. He also has been with Rails 4.2 in his adequate record, as he's deemed it, been making it a lot easier for the database to cache queries generated with Rails. And there's been a bunch of other contributors that have brought in arrays, me, HStore support, JSON support, range support, and a whole bunch of other things from Postgres into Rails. Like I said, we do Ember.js. It is a JavaScript MVC framework. It allows us to deliver rich client-side applications. I'll bring this up because later in the talk, I'm going to talk about how we feed Ember, or how we're going to potentially feed Ember more directly from Postgres instead of Rails. And we use Rails as our backend for all of our Ember apps. So Postgres is awesome for Rails developers that are looking for advanced data types like arrays, HStore, JSON. Like, these allow you to do more powerful things. Especially if you look at ranges, you could store your hotel reservations as a date range instead of just storing it as like it starts here and ends there. Now you can do constraints that say you can't have overlapping date ranges per a specific room. The other awesome features that I've used somewhat, windowing functions we've used on a client app. We have not used table inheritance. I'm going to talk about single table inheritance on the Rails side, not the Postgres side, in this talk. And one that I'm excited about but haven't had a chance to use is schemas, so that we could build multi-tenant apps in one database but have every one of those tenants have a different silo, so you can't have crosstalk between client applications. We're going to talk about arrays today. Postgres has awesome support for arrays. It will support all the native data types and any custom data types you define. And they can be multi-dimensional. You just got to be sure that your multi-dimensional arrays, each child array is the same length. You'll run into errors on Postgres won't allow you to insert jagged multi-dimensional arrays. We're going to talk about HStore. HStore is key value stores. In 9.3, they are stored as strings, so if you're going to take values out of them, you're going to have to convert them. If you store like an age as an integer, it's going to be converted into a string that you'll have to cast back out if you want to do operations on that. We're going to talk about ranking, which is a window function, which we built a high score board out of it in conjunction with common table expressions, which allow you to create subqueries in a cleaner way than just nesting down all these selects in multiple levels. It's way easier to read your more complex queries if you're using common table expressions. And the last one that we'll talk about today, and this is the thing I'm most excited to talk about, is using Postgres' JSON support to serialize our payloads on the database side so that we don't do all this object instantiation on the Rails side and avoid like garbage collection, having to convert a whole set of data that's just going to convert into another set of data. We'll talk about a few patterns that we're going to use these concepts in. We're going to talk about tagging. Most of you are probably familiar with Stack Overflow, familiar with the tags on there. We're going to talk, like I said, Rails single table inheritance. Not a great image for single table inheritance, so I figured put my dog in because if something ever happens to me and my wife, dog's gonna inherit everything. And we're gonna talk about leaderboards and also getting useful data out of leaderboards. Like you have a video game you play and you get the high score. You want to see what your ranks are for your scores. We'll go and talk about how we can get that out of the database easily. So we're going to build a tagging system. We are going to apply tags to notes. We don't care about tag cloud or generating a list of all the tags that exist. That's a kind of a important note of this system that we're going to build because that's kind of a pain in the butt. We are also going to want to find notes with a given tag. So let's say you have a tag search. So you're going to put in a term and you're going to find anything with that tag. So typically the way you do this is with a many-to-many relation. You get the join table in the middle. So you have a table of notes, you have a table of tags. You join them on that join table. And there's a lot of cleanup you have to do. Rails will do this for you if you set up your relations the right way. But if you don't, you're going to have to clean up. You're going to have orphan records. You're going to have to create records on the way through. So you're creating more objects for each time you just want to apply a note to a tag. So instead of creating that tags table, let's just store the tags as a string, an array of strings on our note. So now we don't have to worry about creating those tag records in the join tables and checking to see if the tag already exists. And all that work we would have to do for the many-to-many relation. So with Rails, in Rails 4, it got really easy to add turn a column into an array column. If you see here, we're just giving an option to the migration that says, let's make this an array. Super easy to do. So at this point, we'll say we've injected some data into our table. Now we want to figure out which notes have a specific tag. There's a couple ways to do this. We can use the any. We can check the tags array with any, or we could do a contains operation. With any, it reads like you'd expect, like you say, I want to see if useful is any of the elements of tags. The problem with this is it won't use any indexes. Although we can use contains instead, and it's kind of, if you think about it, you say a contains compares to arrays. So you think, how am I going to make sure that one tag exists in an array of tags? All we have to do is turn that tag into an array itself, and now we can compare the two arrays. And so you're just saying, does that that tags column that's an array have this other single element array? So it allows you to find a single tag. This allows you also to use your gin index so that now you can use indexes to get this value out. So adding gin indexing is pretty easy in Rails as well. We just say when we're adding that index, we're going to use gin. Like I said, Rails 4 is getting better support for all this Postgres stuff that you'd have to just have execute SQL statements in before. So I did some naive benchmarking. I created a table with 100,000 notes and 100 tags, or each with 100 tags, and there was 10,000 possible tags. These times came off of this MacBook Pro Retina, so it has an SSD and 16 gigs of RAM, so it's going to be somewhat fast, especially when there's not much else running on it. So with the old has many, or no, I can say old, but the way you normally do it has many, you'll see that the first operation is like a little over a quarter of a second, and then every time we call that after the fact, that we've called it once, it's going to be quicker because Postgres is going to be caching that array or caching that query on its side. And with what I was saying with what Aaron Patterson was doing, every time you change this tag ID here before Rails 4.2, it would actually be like a first run of that query. In theory, it should be able to do, the subsequent calls should be the same across all those other ones now, since they're moving the dynamic part out of the guts of the array and doing a better, or query and doing a better job of making the queries cacheable.
Can I ask a specific Rails question?
Yeah.
Has many is where you define the model.
Yeah, you're going to have the model one set. Yeah, you're going to have.
Model definition, and then when you, is the right word?
Yeah.
Model, then it does the query?
No, you'd say like you want to find notes, and you'd have to join between the tables and find. This is going to that. It's actually going to the. Oh, sorry. This should be, yeah, it's going to be mapping post to post tags.
Okay.
So there's a post tags table that has the elements that have the post and tag ID, and then joining there. So if we do the any, finding with any, we get this half-second time every time, no matter what we do. Kind of slow. And slower than what we started with the has many example. When we're using contains without the index, it operates about the same speed as the any example. But when we add that gin index, we go from being over half a second to 8 milliseconds. It's a huge jump in speed just by properly indexing and building our query. So we'll going over the results. You can see that our index contains operation is always faster than has many, even when they're both cached. It's a huge performance benefit just by doing some more work on the Postgres side. The one thing that is a pain in the butt about this is that you can't easily create a list of tags, of unique tags. So you can't get the list of all the tags you have in that, because what you have to do is you got to go and get every tags column off every note, turn those into a set of records. So you're going to take that array, turn it into a set of records to be returned, and then do a distinct on that. I was running this query for a few minutes. I gave up on it because I just couldn't get it to finish to that point. And like anything else, the more indexes you add, it's going to be slower to update. But if you're read heavy, write light, it's not going to be that big of a deal. That it's going to be a little bit more expensive to write that record in the first place. The big thing I noticed too with this is that database cache matters. So to warm up any of these queries, I did a table scan just to make sure that that table was in memory, so that we had a general starting point, so that we wouldn't be like doing one query and then another, and then it looks like one's way faster when they both would have been around the same, because now we have the table in memory. Any questions on that stuff? So another commonly used pattern in Rails is single table inheritance on the Rails side. So what you do is you have your model inherit from another model, which is where all the records are going to be stored. And there's a specific column called type on that base table that Rails will use to instantiate other model types out of that. So like if you have a user and you have a Twitter user, there's going to be a user record with the type of Twitter user, and then when it comes out of the database, it's going to instantiate a Twitter user instead of a user. The way you'd handle this before is, say you have Twitter user has a set of attributes, Facebook user has a set of attributes, LinkedIn user has a set of attributes. Either you'd create a model to store all those attributes, or you just make a really, really fat user model that's going to have a bunch of columns that are going to be filled mutually exclusive to some extent. So we can use HStore to actually create a dynamic data store on that user model to store these attributes that we care about. So enabling HStore, which was added in 9.2 as an extension, I think that's right. But in Rails 4.0, again, we're easily able to add this with calling enable extension in your migration. So like I said, Rails is making it really easy to use all this stuff. I'm going to go over an example that I've taken from an example that Joe Him did at DevMind. He was using the Postgres, the active record Postgres HStore gem, which is a library that they use to get HStore in Rails 3.2, but in Rails 4 we don't need to do that because it's already there. We're going to apply the same concepts that he had used in that example, in our example. We're going to make our member class. Member class has a HStore column of data. That's where we're going to store all the attributes of all the models that don't share the username and type information, or the username information. So we're going to say every one of our members has a username, but everything else from there is going to be stored based on what model it is. It's a lot of Ruby code, but what it's doing is giving you a getter and setter on your models based on going into that the column you tell it is an HStore and saying, I've changed that attribute, or it's in storing it in the HStore or getting it out of the HStore. So we use it by just saying that we have an HStore accessor on the data column, and we're going to have email and age. So this will define an email and age attribute on our user model. And at this point, we can run Rails validations against it. So you can see, we can say, validates email, age, presence true. And now if we create a record and don't set those, we'll get it. It will say that the record is invalid at this point. So now we have a user. Let's create a Twitter user. That Twitter user is going to have a Twitter handle on that data column. So they still have the username, which we can set. So the username's Dan, Twitter handle is _Dan. You can see we can get both of those just by calling those getters and setters that we defined before. And you can see here the email attribute that we create on the other model we can't get to because we don't know about it at this point because they're defined in different places. So with HStore, everything is stored as strings and your keys are strings. So if you're going to store an age, you're going to convert it into an integer if you need to do something on it as an integer. What we can use in 9.4 will be JSONB so that we can have nested attributes. So you could have a attribute that stores its own hash, and we can come out with type values. And I'm pretty sure that the JSON support in Rails 4 now does typecasting on the way out. So if it sees it as an integer, it's going to convert it to an integer in Rails. So next, I'm going to talk about leaderboards. So you have a leaderboard. You care about how do I rank against people I know, or I want to get to the third page of ranking because I'm not that great, and I jump down to the third page. So Postgres has this rank windowing function with which we can say, give us the rank, and then we tell it how we want to order that by. So we're going to say we want to order the rank by points descending. This will give us our high scores because the highest score is the biggest one, so we want to descend from there. And at this point, we can say, get us all the scores for Barking Boston's, and then we can see that we have this rank applied from the rank function that gives us the information that we want. So you can see here, my two scores are 2 and 3. So let's just get my scores. I don't care about Brian or Doug right now. So if we just try to call that same method or same query and just say select the records by username, you can see that our rank is now changed. I'm now 1 and 2 because this windowing function is just calling it across the query we're currently operating on. So what we need to do is get all that information and then query against that. So we're going to use a common table expression to define the scores for that specific game. So that will give us everybody's score. And we can just select from that using the common table expression. So we're defining this temporary table, essentially, call it top scores for game, and then we can select from that table. At this point, we can say, get the top scores for the game, and then get my scores from that common table expression. You can see now my rank is the proper count of 2 and 3. And so the way you typically do this in active record is you just put a bunch of SQL in there. Kind of ugly. If you had this in a method, you're going to kind of cringe every time you see it. So with my Postgres ext gem, I've actually added support for both common table expressions and ranking. So with ranking, you can pass it in your sort order, so this will sort by points ascending, and you can run your other predicates against it. And then what we can do is say, I want to get all the scores from this common table expression that I'm going to call top scores for game. And then from there, that common table expression is going to be that query from up here that's getting all the scores for that specific game. And then from that query, we're going to then get the records that have the username Dan. So now we've gone from this wall of SQL here, which is kind of a small wall compared to what I'm going to show in a little bit, to 2 lines of Ruby. So any questions with this stuff before I move on to the thing I'm most excited about?
What if you have like really, really big walls of SQL?
Well, we're going to see one really big wall of SQL, but so you could use Arrow and Ruby and whatnot to generate the stuff. It's depending on what you're going to do. You could have 4. So there's another common table expression method I added that's width. You can do score.width, and you could have you pass it a hash, so you can give it each table a name. So you give it like 4 queries as a hash to that method. Does that answer the question? Yeah. Anything else? All right, so the thing I'm most excited about that I think is going to have the biggest performance gains, and this would apply to other frameworks, but I'm just using Ruby in this example, is JSON serialization. So since there's a bunch of functions in Postgres that generate JSON record or JSON objects strings from records in the database, we can create a data set that looks like this here. And this is what Ember Data expects to come back from the server to be able to instantiate models on the client side. We can generate this all with a really complex piece of SQL. But at the same time, we're avoiding a lot of work in Ruby. So I haven't tested any of this in scale. So this is all mostly experimentation. I actually want to change the way this is happening now that I'm going to talk about in here with different ways. I'll talk about those at the end. But in the performance gains I've been running is just going into Rails and saying, get me a set of records and serialize them. So it's not that optimal in terms of like saying how much better it is, but it's definitely better. You could definitely see performance gains just based on the concepts going to happen. So typically when you're going to Rails for your endpoint, you're going to do a bunch of things. Rails is doing a bunch of things in the back end. It's going to receive your request to get the JSON payload. Then Rails is going to know that it needs to generate some type of query. It's going to send that query to Postgres. Postgres is going to build the data set on their side, serialize it to the Postgres' wire protocol, send it back to the PG gem, which is using libpq. That's going to be turned into a set of strings. Those strings are going to be turned into a set of hashes. Those hashes are going to be turned into a set of active record objects. Those active record objects, typically if you're using active model serializers, which a lot of people are using to create JSON responses from their Rails models, it's going to turn that into a hash and that hash into a string. So you're going to take one string, turn into a bunch of objects, turn those into more objects, turn into one string. So you kind of see if we could go from one string to one string, we're going to save a lot of steps. And with creating all these objects, you're going to create garbage collection pressure. You're going to cause your server to need to collect the objects in memory because now Ruby's a memory managed language. We don't care about creating all these objects, but somebody does, and they need to clean up after us. So in the end, we do all this work, and then Rails just sends a single string of JSON to your browser. So like I said, Rails takes a set of objects, and say you have a date. A date isn't just one object, it's an object of objects. So you're gonna have to store like the day part, the seconds part, and it's like you have the seconds and you can get more stuff out of it. You have methods you have to use and get, like I know I have these many ticks from Epoch, but now I gotta get a date out of there and I gotta get the time zone and all that stuff needs to be stored and used somewhere. Why don't we just get the other part of that too is, like I said, with active model serializers, it turns that into a different set of objects, which it then turns into a string. So you're not just having, if you have 100 records that you're turning into one string, you're not turning 100 records in, you're turning in 100 times n, and then turning those into 100 more objects, and then turning that into a string. So this can be slow. So let's cut out steps 7 and 8. Which is having active record turn a whole bunch of Ruby objects into a string. And let's just have Postgres return one string that we take and just pass straight to the browser. So to do that with this example, we have this huge wall of SQL. I'm going to break it down for you guys. So let's start. We really care about getting notes, and that we want the tags that appear with that note. So in this case, we don't have a predicate on our notes query, so we're going to get all the notes. From there, we may have tags that don't apply to a note. So we want to figure out all the tags we have that only are on the notes that we care about. So if you had a predicate here and you only wanted one note, this would say, find me all the tags that are in that notes table that we created before. So from there, let's generate our tags. We have a set of tags. So Rails creates a couple columns, updated at, created at. We don't really care about sending to the client. So we may want to filter out some of our response. So in this case, we just want the tag name, the tag ID, and the note ID that tag is related to. So again, we're applying that query against that notes that we're calling. And actually, this should use the tag IDs. Oh no, it's the tag IDs, so this is different. So what this is actually doing is this is grouping our tags based on the node ID and creating an array aggregate out of there. So you'll get node ID 1, tags 1, 2, 3, 4, 5. So this is creating that the set of tags records that only have the attributes we care about, and then we're using row to JSON to turn it into a JSON object, doing an array aggregate on that, and then turning that array into JSON. So we're creating an array or a record's going to be turned into a JSON object, which is going to turn into a Postgres array representation of JSON objects, and then turn that into a JSON array of JSON objects.
Is that because you're just filtering out what
You were filtering.
JSON object?
Yep, that's why we have to use this tags attribute filter, because this happens on the record. So we have to use a common table expression to define that record as the filtered down set, and then use row to JSON on that. Also, we're using this select one as match. I'll go into that later, but that's actually so we can put the two different tables or two different arrays of JSON into one record at the end, and then serialize that and send it back. So we take our notes, and we're going to do the same thing. So we're going to say we want the ID, we want the title of the note, we want the content of the note, and what we're also going to do is get this tag ID. So if we go back to the beginning, we have here for Ember data, it wants the tags that it has many of to be returned as a set of IDs on that record. So for it to know that our note, and it's labeled post here because I'm inconsistent, if we want our note to have two tags on it, we need to tell the note record in JavaScript land that it has two notes or two tags with these IDs on it. So that's what this coalesce tags IDs by notes. So that group by we did at the beginning, we're going to take that and do a left outer join so that we may not always have tags on a note. So we need to do a left outer join and coalesce with an empty array so that we make sure that we're always getting records back. Otherwise, we're going to accidentally filter out notes that don't match up with any tags. And then from there, we're going to do the same thing we did with the notes table or the tags table and turn it into an array of JSON by going row to JSON, array aggregate, and array to JSON. This should get easier with I think 9.3 has support of it. We can take I think there is a way to do JSON aggregate, and so we wouldn't have to do these last two steps of array to JSON and array aggregate. We just say JSON aggregate, and it would cut out a little bit of the work we're doing. So at the end of this, we have this notes table here. This notes is JSON. We have this tags as JSON. They both have a column that is match. We're going to join those two on the match column so that they turn into one record, and they're going to have the name tags and notes. This allows us to get that format in the beginning where the root object has a notes property and a tags property. So it's a lot of SQL that we just went through just to create a whole set of tags. Let's benchmark how much faster it is when we're running this against the current way we do it in Rails. It gets a lot faster, at least until my benchmarks prove me wrong when I do them correctly. But with we start hitting this point here. I actually excluded the one note 10 tags because it's slower, but that's not why I removed it. It's just we're hitting this limit here of how fast Postgres can do that. But you can see even on a smaller record, we're still a smaller record set, we're still 5 times faster, which if you're before caching, if you're getting everything faster back, you're taking less load off your application server in allowing yourself to serve more responses up. Because this is the time between Postgres and Rails. So this is getting that JSON string all the way back. So it's not just the Ruby side, not just the Postgres side. It's making that query in Rails and then getting it back. So my biggest concern with this right now in this current iteration is that it's going to put a huge load on Postgres. We're doing a bunch of operations on JSON objects on the Rails, on the Postgres side, and doing all these joins in Postgres. So you're going to really smash your Postgres server. So I've yet to test this really with multiple associations. So if you say you have a more complex object that has like 4 or 5 different relations you want to return with it, this would probably fall over. So the way I'm thinking about handling this in the future, instead of doing that one giant query for each of those separate tables, I'm going to group them. So you're going to do like 4 queries, get 4 strings back, and then combine those strings on the application side. So instead of doing a whole giant query, you're doing 4 small ones, and it's going to be that bridge of doing all the work on Ruby versus doing all the work on Postgres. You should get the performance benefits of both. The other thing I was thinking about, especially with Postgres 9.4, is using materialized views to do that filtering we were doing up here. So you could have a materialized view that is doing like this operation here, this tags attributes filter, or this notes attributes filter. And that way you're storing a view of what you're going to serialize at the end. So now you're allowing Postgres in the background to do a little bit of work to update this stuff, but caching it as well. Especially if you're not having these records change a lot, you're definitely going to see performance benefits because you're caching these queries, or you're preloading these user record sets before you're done, or before you run the query.
Did you happen to compare how much data was actually going across before and after?
It shouldn't. So it would be split. It's going to actually be less because you're going to be getting with the Ruby side, unless you're filtering down your select set on your queries, it's going to be getting the full Ruby object and then filtering it down from there. So you're going to get all those objects. So if we're actually filtering out some of the attributes we care about or that we don't care about, we're not passing those down the wire. So it gets a little bit shorter. So I built a gem to do this. It's in like a 0.02 release right now. But all you do is you define your serializations with active model serializers, and it monkey patches that gem to do all this work. Probably going to move away from there because a lot of the things that they're doing on the application side don't make a ton of sense to do on the Postgres side because they're taking a lot of context in based on like your current user and all that stuff, which you can kind of do, but we're gonna get to this point where it's like, why don't you support this out of active model serializers? And it's like, it doesn't make sense to really support. So why don't we break that relation before it gets to be a pain in the butt? The other thing I want to play around with is doing the things I was talking about, where it's like with the materialized views, you essentially define a migration that sets your view up for your JSON response. So you can keep those migrations. You're going to keep those migrations around. So now you have a history too of what your different versions were. Any questions on this? Because I'm about to wrap up. So Postgres is really awesome. I don't need to tell everybody here that because we're all here because it's awesome. So big things to really take away from this is don't just do this because it's cool and it looks like it might work. We actually test it and make sure it's not going to be a pain in the butt for you to maintain down the road. Especially when you're going away from common patterns. When somebody else picks up the project, they're going to have to discover the work you've come up with. And so if it's not the best fit for you, don't use it. Any questions? Yeah.
So when you were benchmarking Ruby against generating the JSON inside of Postgres, were you using active record, meaning that it was going through the full, let me inflate your model object and everything?
Yep.
And have you tried benchmarking it just using underlying pgcon?
I've
That would maybe, because to me, it seems to me that would probably be much closer to Postgres.
It would be, but you're also taking out the part that's actually assembling that JSON response too. Because if you're not creating the whole response, you're only just getting back a record set, which I mean, getting back a record set is going to be quicker. It's going to be the same amount of time. All that time that Rails is spending is really building up that JSON response. Does that make sense?
Yeah, I'm surprised that it's spending that much time. If it's using like a C JSON library, I'm surprised it's spending that much time there as opposed to like doing object construction.
Well, with the way active model serialize is written right now, it actually calls two-way on that relation and gets all the records and then turns them into a set of hashes and turns that hash into a set of JSON objects. So just all that creation of objects to create more objects to create JSON is going to be expensive. Finished really early.
Wow. We're gonna talk about that gem or that method about index concurrently. Can you mention that briefly talk about?
I'll mention that real quick, but I actually want to go back to this too. We can take, with doing this type of work on the Postgres side, if we add the right indexes too, getting these, getting like the count, this tags IDs, we could use index only scans, which are going to speed those up as well, because now we're just getting that information out of the index and not having to go get the records and then do a table scan potentially. So I can talk about that real quick. Yes, or real slow. I'll talk about real slow. So I'm pretty sure I got this commit in. There's a way to do concurrent index creation Let me see. I'm trying to think of the best way. Actually, we can jump into some of the code too that I wrote to. You can see how bad my benchmarks are. Let's dive into some code.
Can you bump your font up a bit?
Yes. So actually where I'm doing the benchmarks here is I'm calling the active model serialize method, which is how it's doing the serialization. And so my gem patches that. So if you look at this, it's all pretty much the same, except there's a couple options passed to the Postgres one to use the patched serializer. So I feel like these are decent benchmarks, but they probably could be better in terms of just trying to get rid of some of the variables between like having different runs and having stuff in memory and having stuff cached. I've tried switching around, like having my stuff run first and then having the active model stuff run second, so I'm not using their caching of their queries to power up mine. But what I'm trying to remember where it's stored and how you actually call it. But you can actually, with Postgres, you can create indexes concurrently. Actually, I can jump on the Wi-Fi and find the issue related to that.
Should probably use the Silva one. It's much better than.
Is it?
Yeah, this one it'll just.
Yeah. You know the password? Hotel Chicago.
Silver. Let's go to Rails. Wait for it to connect. There you go. Okay. Choose. Here it is. Oh yeah, it was. I did get in. So what you can do is you say, I want to add this index concurrently. So if you have an existing table filled with data, I want to add an index to it, you can tell Postgres to do it concurrently, which will what it allow it to do is do it in the background and not lock your table. So you're not going to lock up your whole database table just to create your index. The one thing to note with this is that you have to disable Rails's transaction. So you have to call this disable DDL transaction, because everything Rails does in its migrations, it wraps in transaction so that if it bombs out, it can roll it back and not blow away your data. So you have to disable that because Postgres won't build concurrent indexes in a transaction.
There's another large caveat here, which is that if the migration itself is still blocking. So when you run the migration on a live server, it can stop at that step for 5,
Yes.
6, 8 hours. And so if you're inside of like Puppet or Chef or anything like that,
It's still sitting
that
there.
timeout can fire off, and then your database is in a
Weird state, yeah.
consistent state.
And when it fails concurrently, I think you have to drop the index and re-add it.
Yeah, it has like a corrupt version of it.
Yeah. We can actually look at, I'll pull it up real quick. It's actually in the last slide. So I have a bunch of links in here of stuff I talked about. 10 to 11.
Is there any way to make it do a concurrent index build outside of a migration?
That's what this is here. You talking about outside of the migration entirely, or? I mean, you could just connect to the console and do it.
Well, yeah.
But,
You pretty much have to, because the libpg or libpq, even if you do it in like pSQL, it's still never, it doesn't return until it's finished making that index.
Right, but the problem is we don't want to hold the migration open for the duration of an index build. Some of ours are days for concurrent index builds in our environment. So obviously running a migration with a concurrent index build in it and letting it sit there for 36 hours is probably not optimal.
you could always spawn a process and then do it there. Still you're gonna lose track of it too at that point, right?
I mean, at some point, when you're getting really nitty-gritty with database performance and stuff, you're gonna have to break out of the Rails mode for specific operations.
Yeah.
You know, I mean, I do a lot of support for people running Rails, and sometimes do this with your query. And they'll say, oh, well, active record doesn't let me do that. I'm like, well, that's what find by SQL is for.
And also, like, if you, it's nitty gritty, but you can dig into Arrow and do a lot of stuff. That's actually what I find myself doing to keep, to watch out for SQL injection, because Arrow will do some type of casting to it to prevent you from really shooting yourself in the foot as easily as possible is with like find by SQL if you're doing string interpolation. But I'll write a bunch of Arrow by just going like, I want this column that's equal to this or greater than this, instead of doing a like find by SQL or where that's a string with a parameter passed to it.
Combined with Arrow and
Arrow is actually the underlying library that Rails uses to create its database queries. So,
It's Rails 3, right?
yes, and it was originally relational. I think it was going to be a relational representation. It's actually a giant syntax tree, is how it's run right now. So you create leaves down you create a syntax tree down the whole path of like, from here I want to do this type of addition. I know this too because I've dug into with PostgreSQL. That's all of what it does right now. Because before Rails 4 came out, I was actually adding support for like having ranges, having arrays, having that. And when Rails 4 came out, I got to delete a bunch of code, and that made me happy because now I don't have to maintain it. But a lot of what this gem is doing is it allows you to query stuff a lot easier. So here's that with example that I was talking about earlier. We just say, is that readable? I'll blow it up a little bit. So just a hash. So you can have as many arguments to this with as you want, and it'll just create the correct query out of it. You can also do recursive. Somebody made a PR, and you can do recursive common table expressions as well. From CTE is a little trick I did that takes allows you to query against a common table expression and return it as the model instance that you're calling it from. So your scored common table expression is going to be a subset of the score information, so we can create score records from that. So that's what from CTE kind of takes its inspiration from find by SQL. And then the other thing I added is support for doing array operators. I haven't got around to all of them. I've just got around to the ones that I've been using. I'd like to add all of them, but you can say where the nicknames overlap with this array, and you can actually just pass an array, and that the gem itself will turn that into the Postgres representation of an array and do the comparison. Same with contains. It also works on internet addresses or IP addresses. So we're able to say find records where the IP is contained in this subnet, which is pretty useful if you're going to say, like, if you're writing an analytics platform and you're keeping all the records of the visitors you have. So adequate record was the thing I was talking about earlier. Tenderlove loves to have funny names for things. It's pretty awesome because instead of, this is the way Rails used to do its finds. So it's when I get me the post with the ID of 10, instead it turns it into a query where that dynamic part is passed in. So now it's able to get huge performance increases. Let me see the graph. So it got worse when we went to 3.0, and then a little bit worse with 3.2, get a little better at 4, but now with 4.2 we're getting better speed with finds because now they're cached and they're able to be cached better. And he's doing a lot of work too to make it so that most queries you generate go through this way, so that we can get huge performance gains in general with what he's been doing. And this has actually been merged in for Rails 4.2.
what's 4 point? What does that mean?
I know they're in betas now, I think. I think they're aiming for Christmas time release, last time I checked. I know GitHub just got onto Rails 3 recently. They've been running a custom build of 2.3 for a long time.
You have some custom, was it 2.1 or something? 1 point something? Yeah. It can't even be upgraded, that's how packed it is.
Nice. So any other questions? I got nothing else really for you guys.
I'm sorry?
You're going to be running it against Ruby versions of that.
Oh, yeah, we're running, yeah, we're gonna.
Yeah, because I think Rails 4.0 dropped support for 1.8, and did it drop for 1.9 as well, or is 1.9? Yeah, I know Rails 5 is going to be 2.2 and above.
So yeah, we have one set of applications on that, and then we started a new architecture on, I don't even know what that is, but a newer version of Rails 3. There you go. And I think someone's working on upgrading it all before. I don't know where else is.
We're upgrading to Rubinius.
Yeah, have you heard of Rubinius?
Rubinius, I've heard of it.
Yeah,
That's the Ruby written in Ruby, right?
Some,
Yeah.
some.
It's actually a great way to learn some of the Ruby source code if you're familiar, since you know Ruby at that point. If you look at Rubinius, you can see some of the stuff that would typically be in C in Ruby. So it's a way to dig into some of the inner workings of Ruby itself. All right, thank you.